Good morning, everyone. Let's continue with our classes. So, as usually, I'm going to go through all the figures in this chapter. Today, we have to learn about memory. So, I'll go through the figures so it'll be easy for you to read the text, but you have to read the text to understand all the figures inside. So, the first one we see, the first figure, 24.1, it's a figure depicting different types of memory. So we have two big memory types called non-declarative and declarative memory. And for declarative memory, we further divide them into memories for facts, called also semantic memory, and for events, called also episodic memory. So this declarative memory, the main characteristic is that it's a kind of memory that you can declare, you can speak, you can explain with words. So you can remember, for example, when was the last time you went to a restaurant, and you can remember what restaurant it was because there is space and time. It's related to space and time. On the other hand, memory for facts, called semantic memory, is not related to space and time, but you can also declare with words. You can explain, for example, what a neuron is, what a computer is. So it's knowledge about the world. And you can see the brain areas related to this type of memory are the medial temporal lobe and the diencephalon. We will see this further in the different figures, these brain areas. And non-declarative memory is related to many long-term memories that cannot be declared with words. For example, you know how to ride a bicycle, you know how to play the piano, but you can explain, and it's something your body knows. And the important thing is that this is also a type of long-term memory, but it depends on different brain regions as compared to, for example, declarative memory. In this case, you can see the striatum. Striatum, it's basically the basal ganglia. I recommend you to look at the difference between the basal ganglia and striatum. Actually, they are the same thing, but if you group them differently, you can call them different names. Then another kind of declarative memory is the classical conditioning, and we have different kinds of non-declarative memory. We can go even to very, very simple and basic kind of long-term memories that are not declared with words, and those memories are called habituation and sensitization. And why do we talk about this non-associative memory? Because this is the kind of long-term memory. It was studied at the neural level by a group of scientists, and you can train very simple organisms to learn habituation and sensitization. Habituation refers to a behavior related to some stimulus that it is always present. So at the very first time you perceive the stimulus, you respond very strongly, but as the time goes by and you hear it one time after the other, your response starts to be smaller until it usually disappears. Take for example the sound of the phones, cell phones, that ringtone which sounds like a whistle. You first at the very beginning I didn't know it was a ringtone, so I respond very strongly to that whistle, but as the time went by I stopped responding to that. So it's called habituation. And the other type of long-term learning, non-associative learning, is called sensitization, and it is the opposite, kind of the opposite. In this case, you do not respond, or you commonly respond to a stimulus, and after some specific event you start responding to it strongly than before. I don't know, it could happen, for example, if you suffer some trauma or somebody robbed you on the street, you'll be more aware of somebody coming closer to you, something you didn't do before that happened. So that's called sensitization. And then we have the classical conditioning. You know this, Pavlov's dog, Pavlovian classical conditioning. The dog, for example, is it naturally responds with salivate in front of meat. So you pair meat with a bell, the sound of a bell, which is not naturally conditioned with the salivation, and after many repetitions of this combination of stimulus, so you have to present the unconditional stimulus with the conditional stimulus together, and then this, as a result, the response that was prepared originally for the meat will also appear in front of the bell, because you conditioned. It's a kind of long-term memory also, and it's a non-declarative long-term memory. This is a very simple scheme. It shows the memory consolidation and what we know so far. Information comes to you through your senses, your eyes, your ears, and then you storage that information for short time in your memory, or you can work with that information for a while in a working memory, and then you need a further step to consolidate what you just perceived into long-term memory. And this figure shows an example of amnesia, those two types of amnesia, one called retrograde and anterograde. One kind of amnesia, the first one, the figure A, refers to amnesia that happens. You have a trauma and you don't remember anything before the trauma. So where you live, what's your name, what were you doing, you don't remember that. It's a kind of a typical amnesia, so you don't remember anything before that, but you can store new information. Usually this amnesia actually is very common in people who suffer from head trauma after an accident, and they usually recover very fast. And the other kind of amnesia is anterograde. This kind of amnesia happens when you have a trauma and you are unable to storage new information from that trauma. So you remember who you are, where you were born, etc., but you are unable to remember new people, new things, new events. This image, next image, is 24.6, just showing the prefrontal cortex, because it's a very important brain region related to, in this case, working memory. So it's a brain region important to remember things for short time and work with that information. It's necessary for almost everything in our life. So when we want to speak, for example, right now, in order to speak, I need to remember the words I'm going to use, I need to activate them, and then I see the figures and I have to combine my memory information and figures I'm seeing and create a new speech. So this is a kind of things that working memory does. Then we saw this before, we have it again. I recommend you to look. I'll try to look for some links to give to you about this task. It's a very good task to test prefrontal cortex functions and also working memory. This figure shows, like previously, single unit recording. We can see actually these are histograms based on the action potentials, and what they try to show in here is that for some tasks, the task is not shown in this chapter, but we can see this figure is going to appear later, kinds of show a similar task. You show the monkey food, then you cover the cage so the monkey cannot see where the food is, and then you open again the cage and the monkey has to remember where the food was, and you increase this delay, for example in this case 7 seconds, and the monkey has to remember. So what you see in the figure is that figure B, during that delay, after you hide the food, neurons fire very strongly during the delay period until the monkey finds the food. So it means those neurons are firing, and that action potentials are representing working memory processes. So if they do not fire, means the monkey is not remembering. If they fire, means he remembers. And then this image is showing also short-term memory task, working memory task. So on the first one, A, you look at faces, and you have to remember if one of the faces that appears on the test screen was present in the first screen. And the second task, which is a location task, you have to remember the face that appears on the test screen is not the one you've seen, it's not one of the faces you've seen before, but in this case you have to just remember if that face is in the same position as one of the faces presented before. So in this case you'll be wrong. That face was not in any position previously shown. But in the identity task, on the other hand, the test is correct. That face appeared on the first screen. So then you have C is showing the location, the brain areas activated. You can see lateral and medial views of the brain activation for the two tasks. You can see 6 areas in the frontal lobe that show sustained activity correlated with working memory. The 3 blue areas showed greater activity in the facial identity task, and the green areas were equally active in facial identity and spatial location task, and the red area was more active in the location task. Okay, so this will be all for this first video, and we'll continue with the second part in the next video.